All right, guys. Hopefully you got SSS down because we're going to move on to something different now. And so you need to understand that SSS is there, and we have another shortcut now. Moving on to SAS, and you can kind of guess what that stands for.
It means the Russian Special Forces.
Is that what it is? SAS?
Yeah.
Not SS?
Spetsnaz.
All right. So, hopefully you guessed side angle side. And it stands for if two sides of, and the included angle, now we have to be particular about that. We have to know what the included angle means. The included angle is the angle between those two specific sides that are congruent as corresponding parts. And so the included angle has to be the angle right in between those two sides. And it has to be the one that corresponds to the angle in between the two sides of the other triangle.
Yep.
So the theorem reads, if two sides and the included angle of both triangles are congruent, then the two triangles are congruent. Okay? And so, and you can't skip around. You can't go, you know, this side, that angle, and that side. They have to be right in order.
I always say, like, if you can imagine my thumb and my index finger, that angle right in there between those two is that included angle. So if I look at two triangles, I used to always try to manipulate that, my thumb and my index finger, to see, okay, is that the right pieces? So, you know, we know that my index fingers are the same. But now, you know, if I have this one like this and I have that one like that, well, those two aren't the same. But now if I shrink it up and I make it like that, it should be side angle side with side angle side. That's kind of always thought of it.
Yeah, that's good.
Use my fingers.
Yeah. Okay. So they have to go right in order. Side, angle, side. You can't bounce around the triangle and pick whatever side, whatever angle you want.
Yep.
Okay. So out of this diagram, we're trying to find which ones have an included angle between them. And so if you look at that orange one, it's got a single hash mark, an angle, a right angle it happens to be, and a double hash mark. And then if you look at the pink one, it's got a single hash mark, a right angle, and a double hash mark. And so it goes side, angle, side. And so those would be the two that end up being congruent to each other. Okay. And this question, I like this. It says, what's the included angle between? And it wants the angle between AC and BC.
Right.
Well, kind of a cheat here is that whatever's shared,
Yep.
that has to be the angle.
Yep.
And so the angle between the left side and the bottom would be that corner angle down there in the bottom left, but it is also the letter that's shared between those two, and so it's angle C. But that's a critical thing to understand, is the included angle part. All right?
So here is there enough information by siding is there enough information to prove that the two triangles are congruent by side angle side? And so if I look at the triangle on top there, ADB, and then the triangle on the bottom, CBD, is there enough information? Well, here's that reflexive thing again, you guys, and so this is important because if I was just to look at it right now, okay, I would say, okay, well, I got an angle and I have a side, but I don't have a second side to satisfy SAS.
Right.
So we want to use that fact that that BD, that diagonal in there, is being used by both. So that flies in there. So now I have two sides, which is part of my rule, and I have an angle. But is that angle in between where those two sides meet? So I can do my little thing with the fingers, and I can come up here, oh, not there, and then I can come down here, oh, not there either.
Yep.
So there is not enough room by side angle side to prove that those two triangles are congruent.
And this is not going to be one of our shortcuts.
Yeah.
We're never going to have this.
No.
This doesn't work.
Okay? And so there's not enough information there. Okay? So let's look at another one. So now if I have this, okay, oh, hey, reflexive again, I see it.
Yep.
Okay, FH, it's reflexive. So now that's going to fly in. And now I'm going to do my little finger trick. Okay, so I'm going to go just slide right there. Oh, okay, that angle's in between there on that bottom triangle. And then I come over here with my other finger. Oh, yeah, okay, that angle's in between those two sides. So, yes, there's enough information here. Okay? So that's a yes. And if you just use that little trick, to me, that really kind of helps is,
makes
you know,
sense.
where those fingers meet.
Nice pink Band-Aid, by the way.
Oh, thanks. Yeah, my daughter
it's
making
cute.
fun of me.
Oh.
Anything else,
No.
Mr. Critchfield?
No, that fits right in there.
All right, so let's look at this third one. All right, hey, reflexive again. We told you we were going to use it a lot. Okay, so right now, if you would just look at this, okay, there's a lot of extra information you got to be able to pull out of
This one's a
this.
little more complicated.
Yes, okay, so first thing is, you know, the reflexive piece, when you see it there, just bring it up. Hopefully that'll come up first. Yes. Okay. So I know that KM is reflexive to KM. Okay. So I have two sides. I have the side in the middle, and then I have KL is congruent to NM. But remember, this is SAS.
Right.
And so,
And those arrows don't mean those sides are congruent.
that's right.
Remember,
Don't make that
means those are
mistake.
parallel.
Oh, so here comes parallel again. So our transversals, remember we said you guys got to understand those rules of transversals. And so now we look at this, we have to be careful about which ones we actually say are congruent here.
Mhm.
And so there's a lot of different ways to look at this, but we've got angle M, okay, is congruent to angle K. By what rule, Mr. Scritchfield?
Well, if we look at the two sides being parallel by that transversal down through the center, then those would be on opposite sides of the transversal, and they would be in between the two parallel lines. So those are alternate interior angles. Since the lines are parallel, they're congruent.
So would there be enough information right there to show that those two triangles are congruent by SAS?
I don't know. Let me come up here with my new tool here. If I go those two sides on that, then I don't have the angle in between those. If I go these two sides over here, then I don't have the angle in between those. So no, this is not going to work.
Make sure that angle is in between those sides, guys, when you go to prove it's congruent, or else it doesn't work.
So can I use a different angle?
Well, that's what I was wondering. I mean, could we say that
How do I know that's the right angle to be looking for?
that's right? And that's the thing. Can I prove that two of the other angles are congruent? Oh, no, I can't. But couldn't I say that down over here, Mr. Scripps?
Yeah, the other K.
Yeah, the other side of that K there is, wouldn't that be congruent
The
to the
other
other side of the
M.
M?
Nope.
Nope.
The only way that you would get that is if the top and bottom were parallel. Then those two would be alternate interior angles, but we don't know the top and bottom are parallel.
We know they're
So we
congruent.
can't get that. Yeah, we know they're congruent, but
We
not
don't know they're
necessarily
parallel.
They look parallel, but we can't say that.
So that's tricky there.
Yeah.
Okay?
So
And if you still don't understand the whole thing we're doing with our hands and stuff, don't worry. We'll show you again in class the next day.
Yep.
Okay?
So not enough information there. Okay. So remember, anytime we get parallel lines, we got to think back to chapter 3.
Transversals. Yep.
All the alternate interior, alternate exterior, corresponding. We got to remember all those.
Think
Pretty
so.
much anytime you see parallel lines, that's what it's meaning.
Yeah.
You're going to go back to that.
And I think they're going to talk about that here coming up.
Are they?
Yeah, that little helpful hints. There we
A
go.
little help from a friend. So when you're trying to prove angles inside of a diagram, when making congruent angles, they either need to be vertical, because we know vertical angles are congruent. They need to be alternate interior, like we were just trying to prove, or they need to be corresponding. We're not really going to have alternate exterior, because then they would be outside the triangles
That's right.
that we're trying to prove, and so that's not going to help. And so it's really going to be one of those three that you're looking for. And again, the last two would only be if you have parallel lines.
Yep.
Vertical are going to be very easy. In fact,
Yeah.
we're going to have some proofs that make that very easy to use.
You have to be able to see these, though, guys. I mean, or
Yeah.
else it's just going to be a struggle.
Yeah, especially vertical. Vertical are very easy to see.
Yeah.
And then sides?
So when making congruent sides, they need to be reflexive, which on the last page there, you got to see what that looks like 3 times.
Yeah, way easy.
Way easy. Bisector, okay, a midpoint, and addition. Okay.
Segment addition.
Segment
adding-
addition postulate. Yeah.
adding some
So
pieces up. So bisector, it's going to be that you're going to be given a bisector,
Right.
probably.
or a
It'll
right
say-
or a perpendicular right. They're going to take one triangle and cut it in half,
Right,
and then you get that perpendicular bisector.
right. So typically bisector and midpoint, they're typically going to give that to you. You're going to say two segments are congruent by definition of segment bisector, or they're going to give you a midpoint, and so you can say two segments are congruent.
Really, if reflexive is the one we see the most, though.
It is.
Yeah.
Yeah. Yeah.
But it's good information. A lot of good tips there for you guys.
Yeah. This short list here. So this is something different, and this is
Yeah.
something unique. This is a unique theorem that only has to do with right triangles now.
Only.
And I guess we really haven't diagrammed out a right triangle. But a right triangle has very specific pieces, like this pink one down here. There are two legs, which are the two sides that make up the right angle. And then the longest side, the hypotenuse, the one opposite the 90-degree angle, that's the hypotenuse. And so the two legs are the two sides, essentially, and it really doesn't matter which one you call a leg A or leg B or whatever, and then the hypotenuse there. And so this theorem is kind of a shortcut, sort of these theorems that we've been talking about. So in a right triangle, the hypotenuse leg theorem says that if the side opposite the right angle, in other words the hypotenuse, and either one of the other two legs are congruent to the same pieces, the corresponding pieces in another right triangle, then that forces the two triangles to be congruent. Now I know that's not side angle side in the diagram, But this is just a theorem that only in right triangles does this happen to end up being true.
It's actually ASS. But way back in the day, they knew that wasn't a kosher word, so
No,
they left
no,
it
we
off.
don't want to use that one. So,
But yeah, the key to this, guys, is it's only right triangles.
yeah,
You know, and so it's going to be one of the corresponding legs, and really that's the trick, is to make sure those legs are corresponding. You'll typically be able to see the hypotenuse is the longest piece, and you know that's usually the easier one to find.
right.
Just make sure that those corresponding legs are matching up.
Yeah. So the yellowish triangle at the bottom there is kind of the odd man out because that double hash mark is not the hypotenuse. It's not the side opposite the 90. So it's not that one. But the blue one and the pink one are the ones that end up being congruent to each other by HL. And again, that stands for hypotenuse leg. So this is kind of the odd man out here as a shortcut and so on. It just kind of gets thrown into this section in the book and is just kind of a separate thing. But you need to see it. Anytime you have right triangles, you need to look for this.
Right.
Because this is a shortcut
Definitely.
for right triangles.
Definitely. So if you guys see a right triangle, you got to think, could it potentially be hypotenuse leg? If it's not a
Right.
right triangle, just cross it off your toolbox.
Right.
You know, you won't need it.
Mm-hmm. Yeah. So I think it circles, yeah. So it circles the blue and the pink as being the two that are congruent. Okay. So here's some examples for that.
Yep. Is there enough to prove? So, you know, just to think here. So we're really looking at two different things in this section. You know, hypotenuse leg, side angle side, and then side may come into the mix. But really, we're in side angle side and hypotenuse leg. So if you look at that first one there, I can automatically discount hypotenuse leg. Why, Mr. Scritch?
Not a right triangle.
Right. It's not a right triangle. Okay. So if it's not a right triangle, hypotenuse leg is out. Okay. So now I just got to think, does it fit within side angle side? And so we should be able to see, okay, CD. There it is right there.
Bireflexive again.
Bireflexive again, okay? That's congruent. So now I just got to do my little dealio here, and I got to check. Okay, so where those two sides meet, right there. Oh, I don't have an angle that's congruent there. Check the bottom one now. Okay. Oh, doesn't work. I don't have that angle that's in there that's congruent. So there is not enough information. Now be careful here, because it's almost like hypotenuse leg if you don't recognize that. Because here's your, if you thought
that
because
was a
those
right
are
angle.
congruent, yeah, if you thought those were congruent, which made them 90 degrees, this would work by hypotenuse and leg, but it's not, guys,
Yeah,
okay?
right
You
angle.
need to have a right angle there. You got to be real careful,
Yeah.
okay?
Yeah.
So then the next one, now it's just a matter of manipulation. Now, remember on that thing that said a little bit of help, where you might have to use some addition? And this is that case, because when you talk about side LN and side LS, okay, N to R is 1, and R to L is 1, okay, you put those together and you get that one long length, and then LT has one hash mark and ST has one hash mark, so they're technically the same. So if we add those lengths together, that allows me to say that LS is congruent to LN. And so there's my hypotenuse. It's a right triangle, so now I've got hypotenuse leg in the mix, and then side MN. Now here's where you got to be able to manipulate these. Side MN is the same as side RL. Those are the short legs of that right triangle.
Right triangles, yeah.
Okay, so it's kind of, you know, it's a little bit of different information there that you got to be able to use out of both triangles. And so then, therefore, there's enough information by hypotenuse leg.
Maybe another way of looking at those hash marks is that if each one of them kind of represented a 1,
Right.
you know, if L to R was 1 inch or foot or whatever, R to N was another inch, then that length LN would be 2 inches. On the bottom, L to T 1 inch, T to S 1 inch. So the overall length of L to S would be 2 inches, and so they're both 2 inches, so they're congruent to each other. And then the top is 1 inch. The side of the bottom right triangle is 1 inch, and so they end up being the sides that you need for hypotenuse leg.
I mean, just
A
once
little bit of
again,
a tricky diagram, though.
yeah, and that's what I was leading into. You got to be able to visually unpack these triangles and kind of make some connections with them. I mean, it really is being able to manipulate the drawings mentally.
Yeah, being able to pull those apart from each
Yeah.
other. Are these congruent? If so, which postulate proves congruency? And so we've got kind of the orange triangle on top, blue triangle on the bottom, single hash marks on the side, so those sides are congruent. The top and bottom have double hash marks, so those are congruent. And here's our friend again. They share that middle line, and so reflexive comes in once again. And so the two triangles have that middle line as a side, and so if we were to pull them apart from each other, that side would be exactly the same length. And so by reflexive, that piece would be congruent there, and so by side, 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 these two triangles are congruent.
And you really, guys, you have to start thinking, up to this point, we've got side, 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 side angle side, and hypotenuse leg. Okay? So you got to start eliminating them. So hypotenuse
Hypotenuse
leg,
leg first, yeah.
yeah, it's gone. Not a right triangle anywhere. So that's out. And then, you know, you got, okay, so I got side, 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 or side angle side. Well, if all I can really pull in right now is that price in the or the piece in the middle, the reflexive piece in the middle, go right to side, side, side. You don't need any angles.
Yeah.
You know, so it's just, what do I have? You know, what's the right tool to fit the bill?
There's no angles marked in here, so you
Yeah.
really wouldn't go there. And the only way you would get to angles is if you had parallel lines marked.
Right.
You don't have any parallel lines marked either, so angles are not an option here.
And the reason I like this slide is because it pulls SSS back in the mix. It's like, oh, we learned that, check it off. It's never going to come back again. That's not the case.
Yeah, yeah, we
Okay.
always have that. Yeah.
Yeah. So are these congruent? If so, which postulate proves congruency? So here's our first look at vertical angles here.
Yeah.
Okay, and so if you look in the middle, those yellow angles are congruent to each other by vertical angles. So now I just do my little check. It's not side, side, side because I don't know anything about this or anything about that. So side, side, side is out. It's not hypotenuse leg because there's no right angle in there. So that's out. So now, are they congruent based on side angle side? Well, I just take my thumb, put it right there. My thumb represents 1. My index finger represents 2. There's that yellow angle. Then I come over here, do the same thing on the other side. My thumb represents the 2. Turn my thumb over. My thumb represents the 1, and my index finger represents the 2. And that angle's right in between my fingers.
And
So-
you can imagine how often we have this diagram. All that is two lines intersecting, and then you connect them to make triangles. We get this over and over and over again.
Yeah.
We see vertical angles constantly to set up triangles to be congruent.
It's Batman really angry.
Is it?
Bat eyes going in.
I'll take your word for that. But if you look at this diagram, you can see how we would get that lots of ways. Maybe that's a midpoint of each of them. Maybe each of them bisect each other.
Right.
Whatever. We could get those sides lots of different ways to prove these triangles congruent. So you're gonna see this. All right. And so we're just gonna spend some time practicing proving triangles congruent
Yep.
by these methods that we have so far. And so we'll practice some more in class, guys. We'll see you there.